No, we're really good at this stuff, actually. So, think about the theme of this unit. We've been simplifying square roots, adding and subtracting roots, multiplying and dividing roots, rationalizing denominators, and then that led us into solving quadratics correctly, right? And so then we solved quadratics by completing the square quadratic formula, which just was more radical stuff, or just taking square roots. So today we're going to be solving other types of things. And first of all, we're going to look at things that are quote-unquote quadratic in form. So if you remember, a couple tests ago, we were factoring. Remember that huge factoring one? We factored these, quadratic in form. Factoring helps us solve easily. So what makes this quadratic in form? Well, first of all, looking at the pattern here. Yeah, 4, 2, constant, right, everyone? 4, 2, constant. That makes it quadratic in form because that looks really similar to 2, 1, constant. It's going down in even increments here. Does everybody see? Yes? Yes. Okay, so this would be quadratic in form. So we learned how to factor that with a u substitution. So remember, x to the fourth is really x squared squared minus 4x squared minus 12 equals 0. So what would my u substitution be? U allows us to write it easy in a better way to factor it easier. U is x squared. Good, way to remember. So then we'd say, so this is really u squared minus 4u minus 12 equals 0. So now we'd say we can factor that. What multiplies to be negative 12 and adds up to be negative 4. 6 times 2, negative 6. Can I quick factor? Yes. So we have u minus 6 and we have a u plus 2. Now from there you'd say, but u's not u. U is really x squared. So we have x squared minus 6 times x squared plus 2. Now that is what we did in the factoring unit. So now from here, we're just going to solve. Keep going. It says solve. So wouldn't we, once we factor something, don't we set each of them equal to 0 and solve? Okay, let's do that then. So we have x squared minus 6. Set that equal to 0. We have x squared plus 2. Set that equal to 0 and solve. So we'd add 6. X squared equals 6. Then we take a square root. X is equal to plus and minus what? Root 6, guys. Right? Square root both sides. We need a plus or minus. Okay, awesome. With this one, we'll subtract 2. So we have x squared equals negative 2. So then we'll square root both sides. So we get x is equal to what? Plus or minus? I root 2. Now check. If it's degree 4, I should have 4 solutions. If you can remember, it was degree 4 at the top. Don't we have 4 solutions here? Awesome. Let's do another one. Let's go on to this one. Okay, so first of all, to solve anything, we need it equal to 0, so we should be subtracting 18. So then we have p to the fourth minus 7p squared minus 18 equals 0. What would my u substitution be? Yep, p squared, right, everyone? Are you noticing a pattern here? Isn't this the part that needs to be the u? U squared minus 7u. So can't you see that that's usually going to be the u substitution part? Yeah, right? It makes sense. So then we have u squared minus 7u minus 18 equals 0. It multiplies to be negative 18 and adds up to be negative 7. 9 times 2? Negative 9. I can quick factor. So we have a u minus 9. We have a u plus 2, which is really p squared minus 9 and p squared plus 2. So then we get p is equal to what? Plus or minus 3. And then we get p is equal to plus and minus I root 2, right, everyone? There's our 4 solutions. Pretty easy. As long as we can remember how to factor by u substitution. Okay, let's look at some that look a little different. Why would this possibly be a u substitution problem? Yeah, it's quadratic in form, he's saying. Look, he said it's quadratic in form, it's just there's a 2x minus 1. So look, squared, degree 1, constant. So what's my u substitution? 2x minus 1. Whatever's going to allow us to rewrite this in as a quadratic. So that would make sense. Then we have 2u squared plus 5u minus 3 equals 0. Now we're going to have to long factor. Don't be the one on the test that gets this far and just gets the wrong answers because you can't factor correctly. So multiplies to be negative 6 and adds up to be 5. Careful because it's 1 and 6 and 2 and 3, but people get this messed up. For this one, it needs to multiply to be negative 6. So wouldn't it be negative 1 and 6? Then we have to drop and break because it's long factoring because of the 2. So 2u squared, negative 3. And then we have minus 1u or plus 6u. I'm going to go with plus 6u to make my factoring easier in my opinion. Factoring by grouping. So I pull out a 2u, then left is u plus 3. I pull out a what here? Negative 1, u plus 3. We pull out our u plus 3. And left is 2u minus 1. Now carefully, you'd say u is not u. U is actually 2x minus 1. Now think about this. You're substituting something back in, so you're going to need to use parentheses. So instead of u, we have a parenthesis, and then we have 2x minus 1 plus 3. Then in here we have a 2 times 2x minus 1 minus 1, don't we? So let's simplify that inside here. Okay, so now right here, nothing needs to be distributed because there's nothing in front here. So inside of parentheses, we get 2x and then plus 2. Right here, I would need to distribute 2 in. That's 4x minus 2 minus 1. So we get 4x minus 3. And now can't we set each of those equal to 0? 2x plus 2 equals 0. 4x minus 3 equals 0. So subtract 2. 2x equals negative 2. So x equals negative 1. There's one solution. Add 3 divided by 4. X is equal to 3 over 4. There's our second solution. Was it degree 2? Yes. So we found them all. Are we good? Do another one kind of similar. Okay. Once again, these are pretty straightforward. So you're probably just being able to watch. What would be my u substitution here? Yeah, p squared minus 2. So watching, we have u squared minus 9u plus 14 equals 0. We'll multiply to be 14 and adds up to be negative 9. 7 times 2, negative, negative. Okay, can I quick factor? U minus 7 and then u minus 2, but u is not u. U is p squared minus 2. So we have parentheses, p squared minus 2 minus 7. Then we have parentheses, p squared minus 2 minus, that's a 2, minus 2. Okay, so now what is this actually? P squared minus, is that a times sign? No, it's a subtraction sign. So it's p squared minus 9. And then right here, we have p squared minus 4. So then p is equal to 3. P is equal to plus or minus 2. Now, everyone, was it degree 2 or degree 4? This threw me off for a second in first hour. I looked at it, I'm like, what the heck? I should only have 2 solutions. But no, I shouldn't. Look, squared and squared. So it'd make it 4. That's breaking the forbidden rule, just squaring it. But if we did multiply it out correctly, we get degree 4. So it's actually degree 4. So we're good. It was degree 2 on the last one, yes. Okay, awesome. Now understand, what's the difference between this and any equation in the past with radical equations? With radical equations, weren't we changing the problem? Like do this to both sides. Yeah. We didn't do anything to this. We've literally just rewritten it in an easier way to solve. We didn't change anything, so we would never have extraneous solutions for this one. So we didn't change it. We just rewrote it as something different. Same thing though, right? We're not manipulating both sides. We never said do this and this to both sides. Do you see what I'm saying? We don't need to check for extraneous solutions when solving this type. Not that it would hurt, because it wouldn't hurt to check your solutions. Okay, this one always throws people for a loop here. 3x minus 5 root x minus 2. Now, guys, we're going to have things come up on tests that we've never seen before. And you kind of got to draw from your knowledge of what you've done in the past and kind of say, maybe I should do this. So, looking at this problem and all the problems we just did, what if you had to guess? Let's pretend you had no idea and you had to guess where to try to start. What would maybe be a u substitution? What would a u possibly maybe be? So root of x. Now, you went with what you were seeing in the past, right? A pattern. You've seen a pattern in the past. You're like, let's try that. Well, yeah, he's right. Why did he choose that even if he didn't know what he was doing? Let's pretend he didn't even know. But why is he using common sense? What have we done every time? What has been our u substitution? The part that's right here, right? That part has always been what our u substitution would be. Well, it actually turns out to be he's right. So let's think about why this is. Isn't this really this? 3x to the first minus 5x to the 1/2 minus 2? Well, isn't it going down in even increments then? 1/1/2 constant. Does everybody see? So it's the same pattern here. So now why? So let's see. Well, how do we know if we truly made the right u substitution? So we're saying let u equal 1/2. Well, then wouldn't this need to be, isn't x to the first our u squared? That must be our u squared, right, everyone? So let's see, does that really work? What's our u? Our u is x to the 1/2. Is 1/2 squared this?
Yeah.
So it truly is the correct u substitution. You see how to check. Okay, so it is the true u substitution because raise a power to a power and you multiply. So u squared is the first thing. So we've done this right. So then we have 3u squared minus 5u minus 2 equals 0. Okay. What multiplies to be -6 and adds up to be -5. 1 times 6, 2 times, 3 times 2. -6, I can't quick factor, so I'll long factor 3u squared minus 6u plus 1u minus 2 equals 0, factoring by grouping. So I pull out a 3u, left is u minus 2. I pull out a 1, left is u minus 2. I pull out a u minus 2, and left is 3u plus 1. Do you agree? But what's u? Square root of x, right? Or x to the 1/2, everyone? So we have x to the 1/2 minus 2 times 3x to the 1/2 plus 1. So now you'd say, okay, so I can set each of those equal to 0 and solve. I'm going to give myself plenty of room here. Okay. X to the 1/2 minus 2 equals 0. 3x to the 1/2 plus 1 equals 0. Let's solve for x. What would I do here? Add 2. We have x to the 1/2 equals 2. What undoes a 1/2 power? A square. Because isn't this, guys, isn't this the square root of x equals 2, everyone? Same thing. So what undoes the square root? Square. So we'll square both sides here. Root cancels out with power. X is equal to 2 squared, which is 4. And then when we're solving radical equations, don't we probably check our solution? Yes. Which this works. Look. Go back to here and plug it in. The square root of 4 is 2. Is 2 minus 2 0? Yes. Okay. What would we do here? We messed up on this in first hour, so we subtracted 1. So we have 3x to the 1/2 equals -1. Then what? Divide by 3. That's important. So then we have the square root of x equals -1/3. Yeah, we could keep going and square both sides, and we get 1/9. But then when we check it, it doesn't work. But why can we stop right here right now and say that one's not going to be a solution from last time? Can the square root ever be a negative? No, it's never, no matter what, I can't solve this one. The square root equals a negative? Never. So that one's not, it's an extraneous solution. So what we did in first hour is we said x equals 1/9, and then we didn't go back and check our solution. If you go back and plug that in, you have this. 3 times, plug in 1/9, the square root of 1/9, so the square root of 1/9 plus 1 does not equal 0. So look, 3, and then the square root of 1/9 is 1/3. So then you have 3 times 1/3 plus 1 equals 0. 1 plus 1 equals 0. 2 equals 0? No, that would have been an extraneous solution either way. We just have to remember when solving radicals, we do need to check, or just remember the radical can never equal, a square root can never equal a negative. Moving on. So our only solution for that one is 4. Which, guys, look, it does make sense. Because, see, I was getting thrown off first hour because I'm like, what the heck? We should only have how many solutions? Don't we go off the highest degree? No. Wasn't it degree 1? No. Right. So I was like, oh, I don't know what the heck, and I just moved on. But I should have thought about it and said, why did I have more than one solution? It's because we had messed up and we hadn't checked our answer. So we had too many solutions. Does that make sense? Okay, awesome. Wow, I love when things work out. I won't go through this one if you can tell me what the u substitution is. U is equal to what? Square root of w, so then this would have just been 3u squared minus 14u plus 8, right? Same thing. Okay, awesome. All right, let's look at this one. What would my u substitution be? X to the -1, right? How could you say, well, what if did I do that right? Then see if u squared is the correct thing. U squared should equal x to the negative 2. Square your u then. So x to the negative 1 squared, is that equal to x to the negative 2? Yeah. You guys see how it's all working out. So then we have 4u squared plus 13u's minus 12 equals 0. Let's continue this one because it does come out a little interesting when solving. What multiplies to be negative 48 and adds up to be 13. Now first hour everyone's like, I don't know. So start listing out. 1 times 48, 2 times 24, 3 times 16, and you're going to come across it. Well, there it is, isn't it? So the negative would be here. Long factoring, 4u squared plus 16u minus 3u minus 12. Factoring by grouping. Pull out a 4u, left is u plus 4. Pull out a negative 3, left is u plus 4. So that we have a u plus 4, and then we have a 4u minus 3. Now u's not u, so isn't this x to the negative 1 plus 4? And then we have 4x to the negative 1 minus 3 equals 0. Cool. So our next step is to set each of those equal to 0 and solve. I debate so hardly on this next part on how to show it to you because there's many ways to think through it. So we have this, x to the negative 1 plus 4 equals 0, don't we? And then we have 4x to the negative 1 minus 3 equals 0. So how would you tackle it? Let's see what you would do if it was you. Subtract 4. So we would have x to the negative 1 equals negative 4. Then there's two ways to tackle the next part. If it was you, what would you do? It's okay if you're wrong. Wrong's better than just sitting there and not knowing where to start. You do what? Oh, I like that idea. So he's saying x to the negative 1 is equivalent to 1 over x. Do you agree? 1 over x equals negative 4. Now solve for x. So you could just cross multiply, right? Everyone? But careful because cross multiply, this is over 1. Really what we are doing is getting a common denominator. You'd say, okay, common denominator is how we solve radical equation, or not radical, rational fractional equations, so times by x over x. Can't we ignore the denominator after that? 1 is equal to negative 4x, so then x is equal to 1 over, yep. So how would we first do what? Add 3, right? 4x to the negative 1 equals 3, then what?
4 over.
Yep, we could do 4 over x equals 3 over 1, right? Get a common denominator because that's how rational equations work, x over x. We can ignore the denominator. So we have 4 is equal to 3x. So then x is equal to 4 divided by 3. Let's check. Right now we have two solutions. Was it degree 2? Yeah. Yeah, but still degree 2 though. Awesome. Yeah. Pretty easy stuff overall. It's not new to us. It's just continuing onwards, actually solving. Okay, we can go through this one or we don't have to, but I just want to see if you can tell me what the u substitution is at least. U is equal to p to the 1/3. So then this would be u squared minus 4u minus 5 equals 0. Do you want me to continue or not continue? Yes, no? No? You just factor it, right? Plug in p to the 1/3. How do we solve a cube root? Cube both sides, right, everyone? How many solutions would I have? This is technically degree 2. We should have 2.
Why?
Because that's the cube root of p squared, so it's just degree 2. It's technically 2 roots, but the power part is the 2. The radical part doesn't matter for the number of solutions. Does that make sense, everyone? Okay, awesome. But it would just be solving a radical equation. Okay, so what I'm going to do is give you like 20 minutes to work on that before we move on to the next lesson. Good stuff. This stuff's fun. Not hard, super basic, solving, easy. We like use substitutions, honestly.